Today we're going to look at different data that we get for weather and also calculations that we can do with these data. So the first one we're going to look at is our rainfall calculations. Now we get different types of rainfall calculations. The first one is daily, then we get weekly, we get monthly, and we get annual rainfall totals. Now, rainfall is always measured in millimeters, and we can plot them on a graph. When we plot them on a graph, it's always a bar graph where our rainfall in millimeters is across from my months. I can also have it as my days or my weeks or even my years. And when I work out my mean, average, monthly, and annual rainfall, it will usually be over a minimum of 30 years. Now we can also classify the amount of rainfall. So when I have between 0 and 249 millimeters of annual, so per year rainfall, this can be described as very low. If I have between 250 and 499 millimeters per annual, then I can describe it as low. Between 500 and 999 millimeters of annual rainfall can be described as moderate. Between 1,000 and 1,999 millimeters per annual can be seen as high. And if I have over 2,000 millimeters of rainfall per annum, I can describe this as very high. Next, we have our temperature data. Now, my temperature is measured in degrees Celsius or in degrees Fahrenheit. And here I also get different types of temperature readings. So I can have daily temperature readings, and this we call diurnal. I can also have my mean daily temperature or my mean monthly temperature. I can also have an annual range and a mean annual range. Now, when plotting my temperature graph, I'll put my temperature across time. And this graph will always be a line graph, not a bar graph like with rainfall. Now, my different temperature ranges can also be classified. So if I have a temperature of below negative 10 degrees Celsius, it can be classified as very cold. If I have a temperature between negative 10 and negative 1, it can be classified as cold. If I have a temperature between 0 and 9, I can classify it as cool. And if I have a temperature between 10 and 19, it can be classified as warm. Between 20 and 29 is hot. And then between 30 and above 30, I can classify as very hot. Now, of course, I don't just have my temperatures, but I also have my temperature ranges. So this is the difference between two temperatures. Now, when my temperature range is between 0 and 3 degrees Celsius, my range is very small. If it's between 4 and 8 degrees Celsius, it's just small. If it's between 9 and 19 degrees Celsius, it can be seen as moderate. And any range of 20 and above, we can see as a large range. Next, I have my wind data. Now, wind is measured as speed, so I can measure it as knots, miles per hour, or kilometers per hour. Now, the direction of my wind is quoted from where the wind is blowing and not where it's going to, and we use compass points. So if I have north on my compass and my wind is blowing from the north towards the southeast, then my direction of my wind will be north. Now, this is very important as this will inform us of what temperature and moisture the wind will be bringing with it. Now, the most frequently occurring wind is called the prevailing wind. An example is the UK's prevailing wind that is from the southwest. Now, my strongest wind is called my dominant wind, and this is usually quoted as a direction. Now, my wind data is usually plotted on a map with wind bars, so no use of graphs. I can also describe my wind speeds. So if I have a wind speed of below 50 kilometers per hour, I can describe the wind as calm, light, or moderate. If it's between 50 and 100 kilometers per hour, then the wind is described as a gale wind. If it's between 101 and 118 kilometers per hour, it's a storm wind. And if it's between 119 and above 119 kilometers per hour, then I can describe it as a hurricane wind, which is a very strong wind. So next we have pressure, and pressure is measured in millibars or MB. Now, pressure is measured based against the average sea level pressure, and this pressure is 1013 millibars. It is not totaled over time, but on a time basis depending on the circumstances. So I would take hourly pressure readings following a storm or a potential storm. I will take daily pressure readings if I want to do a weekend forecast. And I would do twice daily readings if I'm doing a sailing forecast. So here I'll probably take readings in the early morning as well as later in the afternoon. Now, on a weather chart, the lines that join places with equal sea level pressure are called isobars. Now, the isobars identify features like anticyclones. Now, anticyclones are areas of high pressure. We then also get depression, which are areas of low pressure. Now, the anticyclone winds tend to be light and blow in a clockwise direction. Now, this is only in the northern hemisphere. So in the southern hemisphere, like in South Africa, it will go in an anti-clockwise direction. Now, for anticyclones, the air is also descending. So this will reduce the formation of clouds, and it will lead to light winds and settled weather conditions. Now, in depressions, which is our low pressure system, the air rises and will blow in an anti-clockwise direction in the northern hemisphere, so clockwise in the southern hemisphere, and it will be a rising air. So this will cool, causing water vapor to condense, which will form clouds and even precipitation. This is why the weather in a depression is often unsettled. There's usually weather fronts associated with depressions. Now, when my pressure is 113 millibars, that is the same as sea level. Anything above this would be high pressure, so anticyclone, and anything below this would be low pressure or depression. Lastly, we have humidity. Now, humidity is measured using the relative humidity table. So it is measured as a percentage of temperature. We can find it by looking for the intersection of the wet bulb thermometer lines, depression, as well as the dry bulb's temperature line. Now, the temperature will determine the relative humidity. So the more water vapor is in the air, the higher the temperature needs to be to hold that water vapor. So for instance, if the air is 20 degrees Celsius and it holds 4 grams of water, then it will have a relative humidity of 27%. Now, if I add 4 grams more water, which means a total of 8 grams at 20 degrees Celsius, it will have a total of 52%. Now, this can go on and on and on until the air is saturated, meaning that it has 100% humidity or 15 grams of water at 20 degrees Celsius. Now, if I increase the temperature at this point, right, then this 15 grams of water in the air will equal to, for instance, 83% humidity at 23 degrees Celsius, which means that if the temperature of the air rises, it will be able to hold more water.